Welcome to The Explainer. Today, we're diving into the incredible detective story behind one of the most famous symbols in all of science, the periodic table.
I mean, just think about it for a second. Imagine you're a chemist back in the 19th century. You've got this growing list of elements. You've got fiery sodium, super dense lead, poisonous chlorine, and they all have their own unique personalities, but there's no rhyme or reason to it. It's just a big, chaotic mess of substances. How would you even begin to make sense of it all?
Well, that quest to find a hidden pattern, to draw a map for this chemical universe, it had to start with a really basic question. What even is an element in the first place?
So you had pioneers like Antoine Lavoisier, who started to lay the groundwork. He wasn't just mixing things together. He was carefully measuring everything. And by doing that, he was one of the first people to really nail down what seemed to be fundamental substances. You know, the stuff you just couldn't break down any further.
And getting this definition straight was absolutely the critical first step. You got to know what you're looking for, right? So once all the chemists could agree on what an element was, the real hunt for connections could finally get underway.
All right, so as that list of elements started to get longer, the search for some kind of deeper relationship really kicked into high gear. And this led to some fascinating, even if they weren't totally complete, ideas. They were really crucial stepping stones.
So fast forward to the 1820s. You've got this German chemist, Johann Dobereiner, and he spots something, well, something kind of weird. He saw that some elements just seemed to naturally come in these little families of three. He called them triads.
And check this out. This is what he found that was so remarkable. If you took the atomic mass of the lightest element and the heaviest one in the group, their average was almost a perfect match for the atomic mass of the one in the middle. It was this tantalizing clue. But here's the catch. It only worked for a handful of groups, so it wasn't the universal law everyone was hoping for.
The next big clue came about 40 years later from an English chemist, a guy named John Newlands. And his approach was actually pretty simple. He just started arranging all the known elements in order of their increasing atomic weight.
As he did this, he noticed something amazing. Every eighth element seemed to have properties just like the first one. It was a repeating pattern. He actually compared it to a musical scale, where the eighth note starts a whole new octave. It was a brilliant idea, a real insight, but a lot of people were skeptical. And to be fair, the pattern kind of fell apart once you got to the heavier elements.
But then, in 1869, a Russian chemist named Dmitry Mendeleev comes onto the scene, and he's the one who's going to take all these earlier ideas and piece them together into a system so powerful it would literally change chemistry forever.
Now, like Newlands, Mendeleev started by lining up the elements by their atomic mass. But his real stroke of genius wasn't in just following the pattern, it was what he did when the pattern seemed to break.
And this is where he made an incredibly bold move. Instead of trying to force an element into a spot where it didn't belong, he just left a blank space. He claimed these weren't mistakes. He said they were spaces for elements that we just hadn't discovered yet.
And just look at this. It shows you just how confident he was. He didn't just leave a blank. He used the logic of his own table to predict the properties of these missing pieces. For example, he predicted an element he called silicon, which he said had to exist right below silicon.
And we're not talking about some vague guess here. He was making specific, testable predictions. He laid out a whole profile for this unknown element, from its atomic mass and its density all the way down to its color. He was putting his reputation on the line.
So for 15 years, those predictions just sat there, waiting. And then, in 1886, a brand new element was discovered over in Germany. They decided to call it germanium.
So they started measuring its properties, and the results were stunning. The match to Mendeleev's silicon was almost perfect. Just look at those numbers. This was the smoking gun. It proved his periodic law wasn't just some clever arrangement, it was a fundamental truth about how the universe is put together.
Okay, so his table was a huge success, but there was still one little nagging problem. To make everything fit perfectly, Mendeleev actually had to swap a couple of elements around, which broke his own rule about ordering them by increasing mass. The final piece of this puzzle was still missing.
And it turned out the solution wasn't based on how heavy an atom was. Nope. It was a much more fundamental property, something hidden deep down inside of it.
So in 1911, a physicist named Henry Moseley was doing some work with X-rays, and he discovered that every element has a unique number of protons in its core, and that's its atomic number.
He realized this was the true organizing principle he'd been looking for.
And with that one change, everything just clicked. When you rearrange the elements by their atomic number instead of their mass, all those little inconsistencies that bothered Mendeleev, they just vanished. It perfected the table and gave us the modern periodic law that we use today.
And so this incredible journey of discovery, of trial and error, and brilliant prediction, it all leads us right here to the modern periodic table, an icon of science with its 118 known elements.
So why does all this history matter? Because the table isn't just a chart. It's like a cheat sheet for the universe. It tells you that elements in the same column are going to act alike because their outer electrons are arranged the same way. It's a predictive map that lets us understand how matter is going to behave just by knowing an element's address on the grid. It's incredibly powerful.
You know, that quest for order that started with just a handful of substances hundreds of years ago, it's still going on. And it really makes you wonder, doesn't it? As we keep pushing the boundaries and discovering new elements, what new patterns and what new secrets are just waiting for us out there beyond the edge of our chemical map?